We've recently looked at the derivative of the square root of x by first principles. What I'd like to do is look at the derivative of the cubed root of x by first principles. Now, if you understand inverses and the cube root of x, now if we were to talk about the x cubed function, the x cubed function comes up. Let's do this in black. So the x cubed function comes up, it levels out at a gradient of 0, and then it takes off again. That's the x cubed function. However, we want the inverse, and as you know, there's this y equals x line, and the inverse function would be the mirror image of that, and you can see that at the point when x is 0, it's vertical. So this x cubed function, the cube root of x function, is vertical at x equals 0. So we cannot have the x equals 0 as the domain. But there's a gradient everywhere else. We just cannot use the 0, so it's all real numbers, the domain, except 0, because at that point we have a vertical derivative, so we cannot get the derivative at x equals 0. So it's the real numbers, the domain, except the 0 value we cannot get. So let us have a look at finding the derivative between x, the cube root of x, and x plus h, the cube root of x plus h. So there's 2 points we will go between. I'm just going to change this to x to the third, and x plus h to the third. Alright, now we're going to need a principle of a formula. Well, actually, let's just go into the derivative here. The derivative will equal the limit as h approaches 0 of x plus h to the third minus x to the third over h. Okay, so I want to look at just the numerator, and we're going to replace the numerator. So we'll just, let's come over here and write the numerator, x plus a h to the third minus x to the third over h. Now we're going to use a principle which uses the rule a cubed minus b cubed equals, I don't have enough room, so I'm just going to put a minus b a squared plus ab plus b squared. So this is like an a squared minus b squared rule, which is a minus b times a plus b, but it's a cubed minus b cubed. And I want to change particularly the a into a x plus h. And I want to change the b, actually I want to call that x plus h to the third. And I want to call the b x to the third. Now you will see that's what we've got in our numerator over here. But then continuing, that would be x plus h to the 2/3 plus x plus h to the third, x to the third. Just move this over. X plus h to the third, x to the third, plus x to the 2/3. Now that's going to equal x plus h to the third cubed, looking at that rule, minus x to the third cubed. Okay, so we've got a new formula that we're going to use. I'll put this in black. The formula we're going to use is x plus h to the third cubed. Now if you have third cubed, that's just x plus h, minus x to the third cubed. X to the third cubed is simply x equals x plus h to the third minus x to the third. That's the first bracket. And the second bracket is x plus h to the 2/3 plus x plus h to the third, x to the third, and then plus x to the 2/3. Alright, complicated, but I'm going to leave that on the right. I'm going to take this across, make it divide. Therefore, look at this, x minus x can cancel. So therefore h over x plus h to the 2/3 plus x plus h to the third, x to the third plus x to the 2/3 equals x plus h to the third minus x to the third. Now we had to do that because I'm now going to go back to that purple formula, back to our original formula, and I'm going to continue with the next line. So, actually, we've got the green formula. So let's continue with equals the lim as h approaches 0 up here. That numerator becomes the left-hand side. Because the numerator is the same as the right-hand side, I'm going to replace that numerator with this fraction here. H over x plus h to the 2/3, x plus h to the third, x to the third, x to the 2/3. And then we've got over h, so times a h under the denominator, and you can see that that h will cancel. And let's substitute 0 in for h, and we've got 1 over x plus 0 to the 2/3, x plus 0 to the third, x to the third, and x to the 2/3. You will see that's x to the 2/3 plus x to the 2/3 plus x to the 2/3, so it's 1 over 3 x to the 2/3. And there we have the limit of h approaches 0. That is the derivative by first principle of this cube root of x. Are you able to do that? I hope so, with a bit of practice. If they ask to show the derivative of the cube root of x by first principles, I'm sure that you will be able to place all of that information on your solution. Until I talk to you again, stay happy.